In this lecture, we will discuss about the various values of alternating quantity. This lecture covers the various values such as instantaneous value, peak value, average value, and Rms value as associated with the alternating quantity. Values of alternating quantity. Now, in DC, if we represent a DC with a graph, so a DC will be look like this. Any DC signal. So it means that a DC signal basically or ideally is a constant value which does not change its magnitude or direction with respect to time. Either it would be positive or it would be negative, but it will remain as it is, either positive or negative, right? So it is quite easy to determine its value here. If you want to find out the average value over the time period t, so you can easily determine its value. And because it is not varying with time, so at times we do not even feel to specify the magnitude also because it is already known to us, right? But if we see an alternating quantity, let us take the example of a sine wave. So a sine wave basically, or an alternating quantity, if you see here, so it, let us say it is a voltage or it may be a current, alternating current or voltage. So as you can see, it is varying with time. At every point of time, it is varying. Its magnitude is changing continuously. And also it has reversed its direction here, right? So around this mean position, this may be omega t or time axis, right? So around this mean position, this signal is continuously varying, continuously changing. Okay, so because it is continuously changing, so at times it becomes very difficult, or in fact almost impossible for the users to specify the value of the alternating signal, right? So because we may have a numerous values of alternating signal between two successive instants. So now naturally it comes in our mind that how would we express the magnitude of any alternating quantity, whether it is alternating voltage or alternating current. So what is that way, what is that criteria by using which we can express an alternating signal mathematically or in terms of its magnitude, right? Now there are five ways of expressing any alternating signal, means there are five different values which are associated with the alternating quantity or alternating signal. And these quantities, these values are the instantaneous value, the peak to peak value, average value, and the last is the RMS value, or it is also known as root mean square value. Now let us understand this one by one. Now what is an instantaneous value? As you can make out from this word itself, the value of alternating quantity that exists at instance, right? So you may have infinite number of instantaneous values between 0 to pi, or between 0 to 2 pi, or between pi to 2 pi, or even between two successive points. As shown in this diagram here, for example, from 0 to pi, we have like many values here, many instantaneous value. As you can see, this I1 here is an instantaneous value at some instant 1. Similarly, I2 is an instantaneous value of this alternating quantity. And this is the current basically, right? So I2 is the instantaneous value at instant 2. Similarly, I3 is the instantaneous value at instant 3. Similarly, IN is the instantaneous value at some instant n. So that means this whole period, this whole duration of from 0 to pi has been divided into an instance. So at every instant we have certain value. So you can make out from the word itself. So the value of the alternating quantity that exists at a specified instant is termed as instantaneous value, right? So there may be numerous instantaneous values over the, if you have to find out the instantaneous values over this whole cycle, because one cycle of sinusoidal wave is from 0 to 2 pi, it is for 360 degrees, right? So if you have to find out the instantaneous values over this complete cycle, you may have numerous instantaneous values, or you can see you may have infinite instantaneous values here. Okay, so this can be understood from this diagram as I have already explained. Now let us go further and understand what is peak value and peak to peak value. The peak value is basically the maximum value that is attained by an alternating quantity in its cycle, right? Because here we have seen this is a sine wave. Okay, so this is a sine wave. So let us take some non-sinusoidal signal. So this is omega t axis, and this is some alternating quantity. So it is something like this, for example. So the peak value is this one here, right? So this is the maximum value that is attained by this particular signal. So it will be termed as xm, capital X and small m here. So m indicates maximum and this x indicates the static value, because every alternating quantity will have one maximum value. There would be one peak value. There cannot be multiple peak values, right? Okay, only one peak value exists, right? So in some literature, you will find it like this xp, where p indicates peak and x indicate this is the capital letter. Okay, so it indicates the the peak value of this x, right? Which is the alternating quantity. So any alternating signal will have one peak value, will have only one peak value, right here. So this will be term, for example, this is voltage or current. So it would be either vm or im, or it may be written as vp or ip. Okay, so P is for peak, M is for maximum. So you may have different notations for this peak value or maximum value. So we can also term this value as the maximum value, right? So this is the maximum value of the alternating signal, right? Okay, so this is the maximum value attained by an alternating quantity, and which can be denoted as a Vm or Im or Vp or Ip, right? So we'll write that also Vp or Ip, right? So it is very important to know the peak value of any signal, right? Okay, so peak value is not used to specify the magnitude of alternating voltage or current. What does it mean? It means that though we have the peak value and we have only one peak value for any alternating signal in its cycle, means over the cycle, over the complete cycle, any alternating quantity will have only one peak value, one maximum value. But even though we do not use this value, this information as the information for the alternating voltage or current, means we cannot say that if the peak value of some alternating signal is 20, let us say if the peak value of some alternating current is 20 ampere, we will not say that this is the magnitude of the alternating quantity. So this is not the magnitude of the AC, right? So this is the peak value, but this is not the magnitude of the AC. Okay. So similarly, the peak to peak value. What is peak to peak value? So peak to peak value is um, the difference between the maximum peak, positive peak, right, and the negative peak of an alternating signal over its complete cycle. So you can see from here it is 0 and this is pi and this would be 2 pi for sine wave. So the positive peak and the negative peak, the difference between these two is peak to peak value. So it is written as VPP for voltage or IPP for current, right? Now let us go further. All average value of the alternating quantity. Now, what is an average value? If you have to find out the average value of some, let us say n numbers. So you will add all the numbers 1 plus 2 plus 3 plus so plus n divided by. So this is how you would do it, right? So to find out the average of an alternating quantity, what we do, we generally find out all the instantaneous values of the alternating quantity. For example, if you have, let us say, a non-sinusoidal alternating quantity like this, I'll take the half cycle only just to understand the concept. So this is some time varying signal, for example. So I will take the various values at various instants of this particular signal, and I'll take the average of all the instants. Like if this is the instant 0, this is instant 1, then 2, then 3, then 4, then 5, then 6, then 7, and then let us say 8, right? So I'll take the average of these two instants. So I'll take a different ink here. Just to let us take blue ink. Okay. So I will have some average mid value of this. Then I'll take 1 and 2 ka average. So I will have some mid value of this. Then the instant 2 and 3. So I'll have some mid value of this one. Then I'll have some more mid value. So these mid values are basically known as mid ordinates. So all these are the mid ordinates of this xt, which is time varying signal xt, okay, over this time t, right? So what we do is we add all these mid ordinates. So let us say this is x1, this is x2, this is, let us say, x3, and so on. We have some xn. So what we do is to get the average value of this one, to get the average value of this signal, we add all these x1 plus x2 plus so on, and then up to xn, and divide it by the number of instants, right? So this is how we can find out the average value of an alternating quantity. But this is a method which is generally not well accepted because of various reasons. Okay, because the signal that we have is a continuous signal. So if you see this signal, it is a continuous signal. So a continuous signal may have infinite number of instants. So it may have infinite number of mid ordinates. So how many mid ordinates you have to take, that is a question. Okay, more the number of mid ordinates, more accurate would be the average value, right? So we write here, if the mid ordinates increase, the accuracy of the average value of AC would also increase, right? It is as simple as that, right? So uh, this is how we can find out. So let us see the material. So average value of a waveform is the average of all its values over the period of time. So whatever number of values, whatever number of instantaneous values you have, add all of them and divide it with the number of instants. So you'll get the average value. So for any symmetric signal, so if you have a symmetric signal like this, for example, if you have a sine wave, sine wave is a symmetric signal. So sine wave is a symmetric signal like this. Okay, so it is 0, then you have pi, then you have 2 pi, so it is a symmetric signal. So if you find out the average value for this complete time period t, so the average value, let us say this is a current. Okay, so the average value of this particular would be 0 over the complete cycle, right? Now, what is the reason for this? The reason is that, for one half cycle, if you find out the average value of this half cycle, it would be some positive I average. And if you get the average value of this particular half cycle, it would be minus I average. So if you add them algebraically, you will have zero answer, right? So what to do then? So we'll try to take the average value of a symmetrical alternating signal for the half wave, one half cycle only, not for the complete cycle, right? Okay, so there is one more way to understand the average value. The average value can also be determined by using this mathematical, relation, that if we can find out the total area under the curve and divide that with the base length, we will get the average value. Okay, so what is this? This is something like this. So we'll understand it with the help of a diagram here. So, this is for the mid ordinates, which I just explained. So the average value, this is what I was explaining a few minutes back, that if you have an alternating signal, this is a time varying signal, right? This is a time varying signal. So we have the instant. So this is the zeroth instant, and first, the second, the third, and we had divided the whole, this signal into an instance, right? And then we take the average of these instants, which we call as mid ordinate. These are the mid ordinates. So we add all the mid ordinates to and divide it with n to get the uh, you know the average value of the given alternating quantity, right? Now let us understand this one total area. So if we can calculate the total area of this curve, which belongs to some alternating quantity, this is some alternating quantity. And alternating quantity is time varying. It is varying with respect to time. So if we can find out the uh, area of this curve and divide this with the base length. Now, what is the base length? Base length is the total duration for which this signal exists. Okay. So if we find out the area divided with the base length, so we can find out the average height of this particular curve. So the average height gives the average value. So this particular technique is more effective and efficient in comparison to the mid-ordinate way of determining the average value. Now let us go further. So let us use this formula. We will try to use this formula, average value, total area under the curve divided by base length, to find out the average value of an alternating quantity. And we use the method of integration for this. Method of integration says that to get the sum of all the instantaneous values. For example, from this, let us say this is an alternating quantity. So it exists from alpha 1 to alpha 2. So you have infinite number of instantaneous values here. Infinite number of instantaneous values. So to get the sum of all these instantaneous value, what you do? You will integrate this curve over this duration alpha 1 to for these two limits, alpha 1 to alpha 2. So for these two limits, we'll integrate that this curve, right? So we'll see how we can find out the average value by using this particular technique. So let us consider a small strip over this curve which has the width d theta. So the area of this strip would be, if this is I, this is the AC. AC means alternating current, right? So if this is I, so the area is, let us say dA, so which is equal to, uh, I d theta. So I would be the, the length and breadth. D theta would be the breadth of this strip. So this is very small strip which has this d theta as the breadth and I as the height basically of the or length of the you know region, shaded region, right? So area would be length into breadth, same concept we have used. So if we integrate this area over this alpha 1 to alpha 2, so this would give me the complete area of this whole curve, this one. So I have got the area. So I have used the integration method here to get the complete area of this curve. So where A is the area of the curve, right? So if I divide this A with the base length, so base length is basically this duration for which this signal is existing. So it is alpha 2 minus alpha 1. So it is alpha 2 minus alpha 1. So this will give me, so what is area? Area is height into or length into breadth basically, you can say, or breadth here we can take as height of the signal. So the division of the ratio of area, the total area of the curve to its base length. So this is basically base length. So this will give me the average height. As I mentioned already here, the average height gives you the average value. The same technique is used here. So that means by using this concept, I'll get the average height of the signal, right? So let us see how do we get this one. So the average value of alternating signal can also be calculated through the method of integration. Just now I have explained. Okay, so we may have infinite number of mid-ordinates or instantaneous values over this curve from alpha 1 to alpha 2. So if dA is the area of this strip, it's id theta. So we can find out the total area by integrating this over the range from alpha 1 to alpha 2, means theta 1 theta is equal to alpha 1 to theta is equal to alpha 2. So these two would be the limits of the the integration, right? So the base length here is alpha 2 minus alpha 1. So the total area is this one, right? So now, okay, so this is what we were discussing here. So when we divide the total area, this is the total area with the base length, we will get this equation here. So this gives us the average height. So average height is basically the average value of the curve. Now this curve represents an alternating quantity, right? This curve represents an alternating quantity. Okay, so we will get the average value. So this is the general formula basically that you can use to find out the average value of an alternating signal. Okay. Now, if we specify this in terms of time, basically, so because here alphas, these and alpha 1, alpha 2, theta, these are in degrees basically, or radians. So if we specify this whole, procedure in terms of time, so we can get the average value of an alternating current or voltage like this. So average value of an alternating current is given by 1 upon T, where T is the base length, means the time period. Now, what is the time period? Time period is the time taken by an alternating signal to complete one cycle, right? So, or you can say the time for which the signal exists, right? And then the integrating it from 0 to t idt, similarly for the voltage. So this is how we can find out the average value of current and voltage which is alternating in nature. Now let us go further. Let us see what is RMS value. Now RMS value can be understood as root mean square value. Now what is this root mean square indicate? Root of what? Mean of what? Square of what? So this is what we will understand. So RMS value is also known as effective value basically, which indicates the power transfer capability of an alternating source, or you can say which indicates the the effect produced by the alternating current or voltage in the electrical system or circuit element, right? So RMS value states that, for example, if you have a resistance, it is known as effective value, right? And then, okay, so the average value cannot see. We have studied peak value, we have studied instantaneous value, we have studied peak to peak value and average value, but none of these values is, used to indicate the magnitude of an alternating current or voltage. So it is the RMS value that is used to indicate the magnitude of alternating current and voltage, right? So, okay. Now, the reason why we do not use the average value as the indication of the alternating current or voltage, because over the complete cycle, the average value is zero, but the RMS value will not be zero over the complete cycle. You will see that the RMS value for half cycle or for complete cycle is almost same. Okay, for the symmetrical sinusoidal signal or alternating signal, it is same. For non-sinusoidal signal, it may differ for complete cycle and half cycle, right? Okay, so now we must search. Now, because we know that if we know that this alternating signal is time varying, so it is continuously varying with time. So it is quite difficult to give. Now, what would you say that what is the value of this particular signal? So it is changing at every instant. So because it is changing at every instant in terms of its magnitude, in terms of its direction, phase, so it is quite difficult to set a value. But we need to understand. We need to understand the fact that to analyze the electrical system, to analyze the AC system, to have the analysis of the AC system, we need to have a fixed value. We need to have a constant value of the alternating current or voltage, right? Now, it is that fixed value which is the uh, you know indication, or which is used to indicate or to tell the magnitude of an alternating current or voltage, right? Now, okay, so this now this is always understood in terms of the heat produced or the work done basically by the alternating signal. Okay, so this can be understood with the help of the diagram. We'll come on that diagram in the next slide. So let us see what an effective value or RMS value says. It says that um, the steady current means the DC current basically, which when flowing through a given resistance for a given time produces the same amount of heat as produced by the alternating current when flowing through the same resistance for the same time. So that means we are comparing the two quantities on the basis of the heat produced in a resistance when a DC current or an AC current flows through the same resistance for the same duration. So we'll see what is the heat produced. So if the heat produced is same in both cases, at that point of time we say that this value of alternating current is the RMS value of alternating current, or this value of alternating voltage is the RMS value of alternating voltage. So, for example, when we say that the RMS value or effective value of an alternating current is 5 ampere, so it means that the alternating current will do the work or produces the heat at the same rate as 5 ampere DC produces under the similar conditions, right? So, when we see the current rating or voltage rating of the electrical appliances, right? So these current rating and voltage rating are generally specified in terms of its RMS value. Okay, fine. So whenever you see an electrical appliance of 5 ampere and 220 volt. So this 5 ampere and 220 volt is actually the RMS value of current and voltage respectively of that particular electrical appliance. Let us see it with an example here. What means, let us understand the statement with this example. So if you have a resistance R, right? Okay, if some I, small I is indicated for the AC, and this capital I is indicated for the DC current, right? So when this I current flows through this R resistance for time t, and when this I current flows through the same resistance for same time t, they too produce the same heat. So if HAC is the heat produced by this AC signal and HDC is the heat produced by this DC signal, so these two are same. So this concept is used to determine the RMS value of the AC signal, right? So we can also use the mid-ordinate method here. Now, as far as mid-ordinate method is concerned, so in mid-ordinate method, what we do is we take an alternating signal like this. We divide that alternating signal in n instants, equal instants, so that the time, duration of each successive instant is t by n. So this complete t has been divided into n instant. So every, this will have the same time duration t by n, right? So when this current I1 flows through this resistance R. Now I1 square, it will be I1 square 4 times T by N. So this is the amount of heat produced by this I1 in this R for T by N duration. Similarly, I2 will produce this much of heat. Similarly, I3 will produce this much of heat, and so on. And then you have this is, sorry, square. This is I3. Similarly, In square will produce this much of heat. So the total heat produced by all these mid ordinates is the sum of all these, right? Now, if you add all these values and you see what answer do we get. So let us add. Okay. So I1, I2, I3 are the mid ordinates here. So let us understand the whole derivation here. So if these are this is the heat produced by I1 in R for T by N duration. This is the heat produced by I2 in R for T by N duration, and so on. If you add all of them, you will get this derivation here, taking R into T by N common because it is common. Now, this is the amount of heat produced by the AC source, right? This one. And if we take an equivalent direct current which produces the same amount of heat, this is, sorry, this is, let us say, HDC here, right? So the amount of heat produced is I square RT, where I, this is the DC current, and when this flows in this R for the same duration T, it produces I square RT. Now, when we equate as per the statement of the RMS value, when we equate all of these, we'll get a simplified derivation here. So now you can see this one. You can even see this equation. Now, why we call it as RMS value? Root mean square. Square of what? All the mid ordinate of alternating current or alternating voltage. Square of the mid ordinate values. Mean of all these mid ordinates. So you can see all the squares have been added. So there are n mid ordinates. So you have n mid ordinate squares divided with n. So this is the mean of these squares, and then root of this mean. So square, mean, and root. So you have root, then mean, and then square. So that is why we call it as root mean square value. Similarly, the root mean square value of the alternating voltage can be obtained like this. So where V1, V2, V3, and Vn are the mid ordinate values. So what are the mid ordinates? Mid ordinates are when you divide the alternating signal into n equal instants. So this is the zero instant, this is first instant. So this I1 is actually the average of these two. I2 is the actually the average of first and second, right? I3 is actually the average of 2 and 3. So we are taking the average. So average is basically taken to get more accurate value of RMS, right? Similarly, we can use the method of integration to find out the RMS also, right? It's in the similar way as we have done for the average value. And the concept is very simple here, very simple. For example, if you have a current I that flows through some resistance R for duration dt. So what would be the amount of heat produced by this I in R for dt is I square R dt. This is the amount of heat. This is, let us say, dH, right? dHAC, for example. Now, if you have to find out the total heat produced by this current I when flows in this resistance R for time t, how will you get? You will need to integrate this dHAC for duration 0 to t, right? So we have integrated it here. Okay, so now okay, so if we consider some direct current which when flows through the same resistance R for same duration t, capital T here, so it would produce some heat, that is HDC. So as per the statement of RMS value, if these two are same, if these two are same, so we will get this equation here. So we have cancelled R with R. Now we have this one, we have simplified it here, right? Now you can see. Now what is the difference between mid ordinate in RMS and this RMS, right? In mid ordinate, you have discrete values. You have specific values here: I1, I2, I3, I4, I5, I6, IN. But here, you don't have to have the specific value. This is the benefit of method of integration. You don't need to know the discrete values. You can simply integrate the whole, alternating signal over the time period, and then you can get the RMS value. This is also root mean square. So square of the instantaneous value, mean, because you have integrated it and divided it with the time period t. So this is the mean and root of this mean, so RMS value. So this is how you can find out the RMS value using method of integration. And similarly, the RMS value of the alternating voltage is given by this formula. So in this lecture, we have understood that we have an AC signal, which is basically time varying signal. It is time varying signal, right? Okay, so this signal has various instantaneous values, but only one peak value, and there may be one peak to peak value, right? This is peak to peak. So it has some average value, which is always determined for one half cycle in case of symmetrical alternating signal, and it has one RMS value, right? So we have seen the instantaneous value, peak, peak to peak, and then average. And in average, we have seen two methods: mid ordinate and integration. Then we have seen RMS, what is RMS, and then we have also used mid ordinate to find out RMS and integration to find out the RMS value. So these all values belong to the alternating quantity. However, any alternating quantity is basically specified in terms of its RMS value, right? So this was all about today's lecture. Thank you so much.